based on what we have learned before. Once we have data in variables, we need some mechanism for manipulating that data to solve problems. Data structure is a particular way of storing and organizing data in a computer so that it can be used efficiently. A data structure is a special format for organizing and storing data. Depending on the organization of the elements, data structures are classified into two types. The linear data structure. Elements are accessed in a sequential order, but it is not compulsory to store all elements sequentially, like linked lists. Example of linear data structures are array, linked list, stack, and queue. The other type of data structure is nonlinear data structure. Elements of this data structure are stored or accessed in a nonlinear order. Example, the graph and the tree. Let's take an example about the data structures and we will see them in details. We will start with the arrays. Arrays are the simplest data structure that stores items of the same data type. A basic application of the arrays can be storing data in tabular format. So for this example, we have stored numbers inside a tabular format, and we have stored the characters in another array, and we have an indexed type. And we have the 2D array, which is the matrix. So a matrix is an ordered collection of columns and rows of elements. It's necessary to enclose the element of a matrix within a bracket in mathematics. So we use this matrix in many applications that we have seen in image processing and much more. A linked list. A linked list is a sequence of data structure or a sequence data structure which connects elements called nodes through links. We have head and we have tail, and the end will refer to null. One application, many applications uses a linked list, but one of them is the web pages that can be accessed using the previous and the next URL links, which are linked using linked lists. The stack. Stack is a data structure which uses LIFO order, last in, first out. One application of stack is the JVM, and also we have the history of visited websites in the Chrome. So it will list the latest one that you have visited. Another data structure that we are going to deal with is a queue. A queue is a data structure that uses FIFO order, first in, first out. Okay, so this is the queue, and one operation of the queue is to handle congestion in network. Queue can be used. Also, sending an email that will be a queue. And most of internet requests and processes uses the queue. Now the tree. A tree are hierarchical structures having a single root node. Some applications of the tree are XML parser that uses tree algorithm, and database also uses tree data structure for indexing, and decision-based algorithm is used in machine learning, which works upon the algorithm of tree. File Explorer on my computer, of my mobile, or any computer uses this hierarchy. Another one is the graph. Graph is a data structure where data is stored in a collection of interconnected vertices or nodes, and edges are the paths. Okay, so Some applications of a graph are the Facebook's Graph API uses the structure of graph or data organization, or Facebook, Instagram, and all social media network sites. Every user is node. So these are the nodes that we use in graph. And also Google Maps uses a graph algorithm called Dijkstra that we are going to see in the graph lessons. So these are the data structures that we are going to deal with in details in next